Hi, everybody. What we're going to do today is just kind of review how to come up with formulas for compounds. I'm not going to so much worry about going from formula to name. Most of us need help with going from name to formula. So I'm just going to kind of start at the beginning here, and hopefully everybody will be able to be successful on the test on coming up with balanced compounds. So what I'm going to do is I'm going to share my screen. We're going to take a look at this document over here in a minute. I'm going to upload that on the Moodle page, so that way you guys have access to that. But we're just going to kind of first figure out how to identify one compound from another. There's 4 different kinds of compounds, and we need to know basically how to identify them. And that's going to probably be the biggest thing, is if you can figure out what you're looking at, it's going to be a little bit easier to come up with a formula. Let me get my camera all straight here for everybody. Hopefully that'll help. Okay. So we're first going to talk about the 4 different kinds of compounds. So we've got 4 main types of compounds. And they are molecular. And these are going to be made up of 2 non-metals. Now, you have to remember where your non-metals are on the periodic table. So if we're kind of looking at our periodic table here, sorry, my little crude periodic table, you have got a metalloid line that kind of runs right through here. You should have that marked. It's somewhere around there. You should have that marked on your periodic table, so that way you know where it is. Everything that is going to be, I'm not worried about what's a metalloid. I'm just worried about metals and nonmetals. So this side is going to be the metals. This side is going to be the nonmetals. So when you're first looking at a compound, if it's made up of 2 nonmetals, then you know if it's both elements are to the right of that metalloid line, then you know you've got a molecular compound you're dealing with. Now, the next one we're going to talk about is, we're going to go ahead and just talk about the acids next, okay? Because we'll save ionic compounds for a second. Now, acids are going to be made up of a metal and a nonmetal. Now, acids are always going to start with hydrogen. That's going to be your metal, okay? So they're going to look something like, I'm just going to put H and then some generic something or other X. That is the format for all acids. And when you're looking at acid names to figure out, how you're going to name it, acids are always going to end in the word acid. So that way you know you're dealing with that. Now, this non-metal over here, this could be an element, such as, I'm picking some non-metals here, could be chlorine, could be bromine, could be iodine, could be something like that, some of those non-metals. Or it could be a polyatomic ion. So you have your polyatomic ions that you need to memorize. Any of these paired with hydrogen could be an acid. Okay, so just because it has a polyatomic ion in there doesn't mean you're going to name it like an ionic compound. So naming acids are a little bit weird. We'll talk about that in a little bit. And then the last thing you have are your ionic compounds. Now, your ionic compounds are going to be made up of a metal and a nonmetal. So the first thing I like to do when I'm given a list of things to name, something like this, like your chapter 2 test or your unit 2 test, the first thing I would want to do is just go through and identify what kind of compound it is. And then what I'll do is, if I'm given a big list like that, I'll go through and I'll say, okay, let me name all the molecular compounds first, because your molecular compounds, if you remember, are going to use Greek prefixes. They're going to have things like mono, di, tri, hepta, tetra, things like those. Those Greek prefixes are going to be embedded in the name of those molecular compounds. That's another key to let you know you're dealing with a molecular compound. Now, the acids, again, they could have the word hydro at the beginning. They may not, but they're all going to end in the word acid. So, again, I'm going to identify those as well. Now, your ionic compounds, not going to have Greek prefixes. No dis, tris, pentas, nothing. No Greek prefixes. And they're also not going to have the word acid at the end. They're going to be made up of some type of metal that's going to come off of the left-hand side of the periodic table, and a non-metal off of the right-hand side. Now, it could also consist of polyatomic ions. And I want you to take a look at this one down here. That is a metal type polyatomic ion because notice it has a positive 1 charge. It's the only one we're looking at that has a positive 1. So, metals and nonmetals, they could be made up of elements and or polyatomic ions. I'm just going to put it PI for polyatomic ions. So that's one way to help identify those. Now, you got two basic types of ionic compounds here that we're going to take a look at. You've got metals with only 1 charge, and then you have metals with more than 1 charge. If it's a metal with 1 charge, it's just going to be pretty straightforward. But if you have a metal with more than 1 charge, the name will have a Roman numeral next to the metal. And that Roman numeral is there to indicate what the charge is on the metal. Okay? So that's basically going to be your transition elements. Your transition metals, your transition elements, they're the ones that are going to be in this section of the periodic table right here. Those are the ones that are going to have potentially more than 1 oxidation number. Now, you have to look because not all those transition metals do. For instance, zinc and silver, while they're in the transition metal section, zinc and silver actually only have 1 oxidation number possible, so they would fall into this elements, your metals with only 1 charge. Okay, so now let's take a look at naming some of these molecular compounds. So what I'm going to do is I'm going to pull this paper out, and again, this is also going to be uploaded onto your Moodle page, so that way you've got access to this, okay? So the first thing I'm going to do is just going to go through and identify what is an ionic compound and what is a molecular compound. I'm just going to kind of try to name a few of these. We're just going to go through a few. So I'm looking at number 1 here, and I'm noticing some Greek prefixes, di and tri. That real quick lets me know, hey, this is going to be a molecular compound. When I look at the elements involved, nitrogen and oxygen, both of those are going to fall on the right-hand side. So this is going to be a molecular compound. So I'm just going to kind of go through and identify some of these. That way you can, because again, identification is key. If you can identify them, it's going to make this go a lot easier. Lithium oxide, no Greek prefixes. Lithium is a metal. This is definitely an ionic compound. Sulfur dioxide, I'm looking at that Greek prefix right there. This is going to be molecular. Diarsenic trioxide, molecular. Barium fluoride, no Greek prefixes. This is going to be an ionic compound. Calcium nitride, no Greek prefixes. This is going to be an ionic compound. We'll do about 10 of these. Diphosphorus pentaoxide, this is going to be molecular. Notice the Greek prefixes. Nitrogen dioxide, this is going to be molecular. Phosphorus pentachloride, this is going to be molecular. And then we'll go down here and skip one. We'll go to cesium chloride because I haven't seen too many ionics here. This is also going to be an ionic compound. Now, these are binary molecular, just simple ionic compounds. These ionic compounds on this page here do not have multiple oxidation numbers, okay? So there's not going to be any Roman numerals. You see, there's no Roman numerals in any of these names because none of these metals have more than 1 oxidation number. So let's go through and come up with how to come up with a balanced formula for each of these. Now, for a molecular compound, the prefixes are your subscripts. So this is nitrogen. I'm just going to write N, and that has a 2 beside it, so that's going to be N2. That's it, okay? Do not reduce. So I'm going to put this on the sheet right here. Do not reduce. Okay? The prefixes are subscripts. Okay? So that's pretty much key to molecular compounds. Trioxide, that means I've got 3 oxygens, so N2O3. That's it, I'm done. Okay? Now let me look at another molecular compound, because I'm going to do it the same way. Sulfur is just a capital S. Dioxide, that's going to be 2 oxygens. Diarsenic trioxide, that's going to be the symbol for arsenic, which is AR. I'm sorry, AS for arsenic. I apologize, AR is argon. Arsenic, and then trioxide is going to be O3. Another molecular compound, diphosphorus pentoxide. This is going to be P2 for diphosphorus. Pentoxide, you have to know your Greek prefixes. What is penta? It's going to be 5. Nitrogen dioxide, that's going to be NO2. Phosphorus pentachloride, that's going to be PCl5. And then I'm just a few of them. Okay, now I'm also going to put a key up so that way you can practice these if you want to, and then take a look at the key to make sure you're right. Because I mean, doing them without having a key is kind of silly, right? And then you don't know what you're doing, or you don't know if you're doing them right. So now let's look at just the simple ionic compounds. Simple ionic compounds, we are going to do 3 things. Okay, symbol and charge. Crisscross, and reduce. So these, these do get reduced. Your molecular compounds do not. I think sometimes this is called like swap and drop or something like that. But you need to write the symbol and charge for each element in the compound. You're going to flip-flop them or swap them and drop them, and then you're going to reduce if necessary. So if you've got like 2 even numbers, then you would have to reduce that. So let's take a look at a few ionic compounds. Again, these are simple, no multiple charges or anything. Let's take a look at lithium oxide. So what you're going to do is you're going to look at the symbol and charge for lithium. And if you notice, lithium is in the first column, so this is going to be Li with a +1 charge. And then oxygen is going to be O. And if you look at what column it's in the -2 column. Now, let me show y'all something as far as your... I got a periodic table right here. Let me pull that out. Okay, so here's our periodic table. As far as coming up with charges, first of all, y'all, I put the charges on the periodic table for you, okay? 2, 1, 3. I'm not worried about silicon. Phosphorus is going to be a -3. Sulfur is going to be a -2. Chlorine is going to be a -1. Folks, the charges are listed there. Now, yes, nonmetals can have more than one charge, but here's the trend for charge. I'm going to go ahead and write the trend across the top. Here's the trend for oxidation number or charge. Everything in the first column is going to have a +1 charge. Remember, these are metals. They're going to have +1. They're going to have positive charges. Everything in the second column is going to have a +2 charge. I'm not worried about my transition metals because, again, iron could have a +3 or it could have a +2. So I can't say, hey, they're all going to do this. Then I'm going to pop over here to the boron group. I'm not really too worried about this. The boron, but if you notice all of the metals, notice where I am on the metalloid line. All of the metals is what I'm looking at. These are going to be +3. Now, if you notice your carbon line, you got kind of half that's going to be a nonmetal and half that's going to be a metal. Typically, I just kind of do a positive, -4. So half of the group is going to be +4. The other half is going to be -4. Typically, we don't worry about those because the metals that you're seeing, lead and tin that you're primarily going to be working with have more than one charge anyway. That charge is going to be provided in parentheses in the name. Okay, so you're not going to have to worry about that. And we're never going to worry about charges for like carbon and silicon, so you don't have to worry about that. Now, this is just like hey, we are now going to the nonmetals. Nonmetals are going to be negatively charged. So your nonmetals are going to be -3. Again, you're not going to worry too much about antimony and bismuth. We don't see those too often in our class in Gen Chem 1. Your oxygen family is going to be -2. Again, you're not going to be dealing with polonium or anything. And then typically your halogen family is going to be -1. And then we don't have to worry about your noble gases. They don't have a charge. So if you just kind of remember the charges as you go across, then you don't have to worry about, what all these other ones are. And that's true for any periodic table. So you've got your charges, your general charges, your general trend. So now let's take a look at where I got oxygen -2 from. Well, it's in the -2 column. That's why I got -2. Now you're going to flip-flop those. So the 2, I'm not flipping the charge. I'm just flipping the number. So the 2 is going to come over here. The 1 is going to come over here. So what I'm left with is Li2O. Now, if you want to write the 1 for oxygen, write the 1 for oxygen. You don't have to. It just makes things a little more messier, but I wouldn't count that wrong. Now, let's take a look at barium fluoride. So when I look at barium, barium is going to be in the +2 column. So barium is going to be +2. And then fluorine is going to be -1. So that's where I'm getting my oxidation numbers from. So barium is going to be Ba +2. Fluorine F -1. So I always write the symbol in charge. Then I'm going to flip them, or swap and drop, or whatever you want to call. So this is going to turn into BaF2. Calcium nitride. I'm going to look over here and make sure I get my charges for calcium. You don't have to do this with molecular compounds. You only have to do this with ionic and acids. So calcium is going to be in the +2 column, so calcium is going to be +2. Nitrogen is going to be in the -3 column, so that's -3. So calcium nitride is going to be Ca +2, nitrogen N -3. I'm going to flip-flop those, crisscross those, swap and drop, whatever you want to call it. And then that's going to be Ca3N2. Okay? So that's pretty much how you do basic ionic compounds. Now, I want to take a look at, I'm not going to worry about naming. There's a naming section on here. I'm not going to worry about naming because pretty much naming is not your issue. I'm going to give you the name on these, and you're going to have to come up with the balanced compound in order to get the problem correct. Now, the other type of compound that we need to take a look at are hydrocarbons. These are compounds that are made up of hydrogen and carbon. Now, while they're made up of hydrogen and carbon, the issue here is the carbon is written first and the hydrogen is always written second. So your general format for a hydrocarbon is I'm just making up a number here, HY. I'm just making up letters. That is the order. So a lot of people get hydrocarbons and acids mixed up because while hydrocarbons do contain hydrogen, it's not in first position. Hydrogen is always in first position in an acid. And hydrocarbons, even though the word is hydrocarbon, they really should be called carbon hydrogens, okay? But they're called hydrocarbons. The carbon is always written first. Now, what we're dealing with is a simple type of hydrocarbon called an alkane. That's the ones we're dealing with. This is an alkane. And because it's an alkane, one, that tells you the ending of the word, but it gives you the formula for how to come up with how many carbons and hydrogens that you have. Now, the number of carbons, and it goes all the way to 10. Is going to be used by the prefix that you see, or the beginning of the word. So 1 carbon means you're going to start your naming with meth. 2 carbons means eth, and you're going to have, the ending on the end of this. 3 carbons, here's where people get a little mixed up. This is going to be prop. 4 is going to be bute. Now, after that, it kind of follows the same as the Greek prefixes. You've got pent, hex, hept, oct, non, and dec. So after that, they kind of make sense. So that's how you come up with your prefix, is by how many carbons you have. Or if you know how many carbons you have, that's how you come up with the prefix. Either way. So the number of hydrogens, what you're going to do is use the formula 2n plus 2. N is going to represent, I probably should have put an N there for carbon. N is equal to the number of carbons. Okay? So, if my number of carbons, let's just do one. Let's just try one. So if we've got ethane. Notice the ending, ane. Anything that ends in ane is going to be a hydrocarbon for our purposes. Okay, if it ends in ane, it's going to be a hydrocarbon. So that's your key to letting you know that you're dealing with a hydrocarbon. Molecular compounds are going to end in ide, IDE. Ionic compounds are going to end in ide, IDE, or they're going to have the name of a polyatomic ion at the end of them. Acids are going to end in the word acid. So if it ends in ane, you know you're dealing with a hydrocarbon. So we're going to have some number of carbons and some number of hydrogens, and that's what we're going to have to fill in. So F tells you the number of carbons that you have. And if you remember, F is going to be 2 carbons. So I'm going to put 2 for carbon. Now, how do I come up with my hydrogens? Well, this is going to be 2N plus 2. So if I let the 2 stand in for where the N is, then my carbons are going to be 2. My hydrogens are going to be 2 times 2 plus 2. So my formula is going to be C2H, 2 plus 2 is 4, plus 2 is 6. This is the formula for ethane. It is that standard. Okay, we're going to do that for all of them. So let's try another one. Let's try heptane. Again, you know this is a hydrocarbon because it ends in the word, it ends in the ending, the suffix ane, A-N-E. So you know you're going to have some number of carbons, some number of hydrogens. How many carbons do we have? The hept tells us how many carbons we have. And hept means 7, so I'm going to put 7 for carbons. Now, to come up with the hydrogen count, you're going to do 2N plus 2. So this is going to be C7H2 times 7 plus 2. So that N right there, again, is going to be replaced by how many carbons you have, so that way you can do the calculation. And that's going to be C7H, 2 times 7 is 14, plus 2 is 16. That is the formula for heptane. They're all that way. Okay? So those are your hydrocarbons. Now let's take a look at, and again, I'm going to have this paper for you as well. This one is a crazy document. I do have all of these. I've got a key for all of these. This is just practicing with ionic compounds. This seems to be one of the major problems. And as you can see, we've got polyatomics in here, and we've got metals with more than one charge. So this paper is just all different kinds of ionic compounds. So if you don't have your polyatomic ions memorized, you need to memorize them. There are some alternate ones on the back over here that we might use on homework and stuff like that. So I'm going to tell you right now, there's more polyatomic ions listed here than what you have on your sheet. And that's fine. So if you run across something and you're like, I don't know what the heck that is, then just don't worry about it. Skip it. Because I've got more, again, we did, 50 polyatomic ions. So we did a few more than what we had to. But anyway, let's just start taking a look at these. I was looking to see if cyanide was one of yours, and it is. So this is actually one of the exceptions. Usually what I tell folks to do is on your periodic table, put the IDE on here, because what that means is any ionic compound is going to end in IDE. Any ionic compound is going to end in IDE. When we look back at, I'll get the right paper here in a minute. When we look back at what we just did, let's take a look at these ionic compounds right here. Rubidium bromide, IDE. Strontium nitride, IDE. Cesium fluoride, IDE. Magnesium phosphide, IDE. All of these ionic compounds end in the IDE. Magnesium sulfide, IDE. Aluminum chloride, IDE. So again, and these are all elements off the periodic table, okay? As you notice, your molecular compounds are the same way. They also end in "ide" because you're dealing with a metal you're dealing with two nonmetals that come directly off the periodic table. So there's no polyatomic ions on here. No polyatomic ions on this sheet. That's why everything on this paper ends in IDE, because they're all elements off the periodic table. Now, if your compound ends in a polyatomic ion, do not use IDE. Okay, so that's a clue when you're looking at the name. If it ends in IDE, it's an element. If it doesn't, it's going to be a polyatomic ion. Of course, there's exceptions. Like I say, there's usually, for every rule, there's probably 10 exceptions in chemistry. It's just crazy. So you have two exceptions here, and that's going to be cyanide and hydroxide. Those two polyatomic ions do end in IDE, but they are polyatomic ions. So just be aware of those two little exceptions to our little IDE rule. Okay, looking at this one right here. We have tin with a Roman numeral 2 and cyanide. Again, these are ionic compounds. Tin is a metal. Tin is a metal. The nice thing is, and I'll show you right here, tin is SN, should be element number 50. There we go. Tin, there we go. Tin is number 50, and it has a possible 4 and a possible 2 oxidation number, positive 4, positive 2. You don't have to even look that up. You can just look right here and see. Tin, Roman numeral 2. There we go. So this is going to be SN with a +2 charge. Symbol and charge, crisscross, reduce. These are ionic compounds. That's what you do. So I need to know the symbol and charge for tin. I don't have to look it up. I know the charge. It's given to me as a Roman numeral. Then I'm going to write the symbol and charge for cyanide. Again, even though this ends in IDE, this is that weird one where it's actually a polyatomic ion, and the formula for cyanide is Cn-1. So let's go ahead and write the symbol and charge for cyanide, capital C, capital N-1. Now you're going to flip-flop those, swap and drop, whatever you want to call it. The 2 is going to come over here, and the 1 is going to come over here. I'm going to tell you folks, this right here is a high miss type of question. When your polyatomic ion does not have a number in it, people forget to put, guess what? Parentheses. So this is going to be SN. Whoops, I'm sorry. I should have made it lowercase n. This is going to be SN, and then cyanide is going to be open parentheses CN with a 2. So what I normally do is on my polyatomic ion sheet, I make myself a note, use parentheses. So if you notice, hydroxide does not have a number, cyanide does not have a number, and hypochlorite does not have a number. All these other ones, 2, 3, 4, they remind you to use parentheses. But the hydroxide and the cyanide, you don't see too much hypochlorite, but the hydroxide and the cyanide, there's no number beside the N, there's no number beside the H. So people tend to forget to use parentheses, and that's going to give you a wrong answer. So always remember, it's better to use parentheses than not when you're dealing with polyatomic ions. People will say, well, do I need to use parentheses? Is it a polyatomic ion? Go ahead. You don't have to if you didn't put a number beside it. But just to kind of get in the habit, maybe always use parentheses. Let's take a look at the next one. Lead to hydroxide. Again, right off the bat, another little exception there. Hydroxide actually is a polyatomic ion, even though it ends in IDE. So lead is Pb with a +2 charge, symbol and charge. Hydroxide, the formula for hydroxide is OH-1. Another one people commonly miss, because while they have to add a number beside the H, they forget to put it in parentheses. So that's going to be Pb, open parentheses, OH, and then a 2. I'm not going to worry about the mercury compounds because you're not going to have to worry about those. So any mercury compound on this, when you're practicing, don't practice on the mercury compounds. Just leave them alone because there's some weird exceptions with mercury. Let's take a look at aluminum nitrate. Oh my gosh, this doesn't have a Roman numeral. What am I going to do? Okay, in that situation, this is an element that only has one oxidation number. So I'm going to come over here to my sheet. I'm going to look at aluminum, and I see that aluminum has a +3 charge, period. That's it. Only one possible one oxidation number. So this is going to be Al, symbol and charge. And then I'm going to write the formula for nitrate. Nitrate's formula, polyatomic ion, ends in 8. This is going to be NO3 -1. I'm going to crisscross that, and that's going to equal Al, open parentheses, NO3, close parentheses, and that 3 right there is what I put right there. Okay, so that's where that 3 went. And y'all know that usually, y'all know to, oh my gosh, I need parentheses on there, otherwise I would have 33 oxygens. So this is one where you would probably remember to use the parentheses. It's questions like 1 and 2, where your polyatomic ion doesn't have a number after it that you would forget to use the parentheses. Okay, let's take a look at number 5, iron 3 chlorate. Yay, another one with Roman numeral. That means I already know the charge. So that would be iron, Fe plus 3. Chlorate, you need to know your formula for chlorate. This is one of your polyatomic ions, and that's going to be ClO3 with a -1 charge. ClO3 -1. I'm going to crisscross that. And that's going to be Fe, open parentheses, ClO3, 3. Now, notice I'm not writing the 1. If you want to write the 1, write the 1. I wouldn't count it wrong. So this is how you're going to do those. Let's, I don't think y'all have a bisulfite on your list. You don't have to worry about that one. You don't have a bisulfate on your list. You don't have to worry about that one. You don't have bicarbonate. You don't have to worry about that one. So again, some of these, if you're looking at that going, well, I don't know what that polyatomic is, then just skip it. Just practice on the ones that you do know. Like I said, I've got more polyatomics on this list, and this is tons of practice. You can see a lot of people, this is something folks need practice with. That's why there are 296 possible combinations here. So that way you can just sit and practice ion naming or coming up with formulas for ionic compounds, which are the ones you're probably going to run into most often. Now, the other thing that we need to take a look at is let's talk about acids and how to come up with the formula for those. Again, acids are going to start with the hydrogen and have either an element that it's paired with, or it's going to start with the hydrogen and have a polyatomic ion that it's paired with. So these are your two options, okay? So let's say we have, and I'm going to go with the name to the formula because that's pretty much what we're going to primarily be doing. I'm just going to pick one. Let's take a look at hydrochloric acid. You know it's an acid because it has the word acid in the name. So a good key to help you identify, at least you know it's an acid. Now, all acids are going to start with hydrogen, and then they're going to end with something. This hydro prefix right here lets you know that we're dealing with hydrogen paired with an element. Rather than hydrogen paired with a polyatomic ion, okay? So if it has the prefix hydro, it's hydrogen in an element. No hydro prefix, it's hydrogen with a polyatomic ion. Now, what element could it be paired with? Well, what does this look like? I was going to get maybe another color pen here. What element does that look like? That is telling you what hydrogen is paired with. Now, with acids, they're not going to end in IDE. So acids don't end in, this part of the word does not end in IDE. It's either going to end in ic or ate. Okay? Ic or us, I'm sorry, OUS or IC. So acids end in ic or us, period. If it's an element, it's always going to end in IC. Always. If it's a polyatomic ion, it may end in IC, it may end in OUS, so you kind of, or ATE. So you're going to have to just kind of, we'll look at that here in a second. So what this is this is going to be hydrogen, symbol and charge, because it's still, you're treating it like an ionic compound. It's a metal and a non-metal. And then chlorine is going to be Cl-1. So the formula for hydrochloric acid is HCl. That's it. Okay? So let's look at hydroiodic acid. Again, you know this is an acid because it has acid in the name, and you know it's paired with an element because of the prefix hydro. What element is it paired with? Well, what does that look like to you? This is iodine. So this is hydrogen, H with a +1 charge, and it's paired with iodine, which is I with a -1 charge. So symbol and charge, crisscross that and reduce. This is going to be HI. Now, let's take a look at one that is not paired with an element. So we'll look at sulfuric acid. So notice there's no hydro in front. This is hydrogen paired with a polyatomic ion. Notice no hydro prefix. So that's how you know you're dealing with hydrogen paired with some kind of polyatomic ion. What you have to figure out is what polyatomic ion it is paired with. So we know it's going to be hydrogen. It's going to be H with a +1 charge, and it's paired with something that looks like sulfuric. Well, here's the thing. If it's a polyatomic ion, if the acid ending is ic, which in this case it is, your polyatomic ion ending will be 8. So let's look at our polyatomic ion list. So it's probably going to be, because it's sulfuric acid, it's going to be sulfate or sulfite. Our name of our acid was sulfuric. So if it ends in ic, that means we're going to use the 8 polyatomic ion. So that means it's going to be sulfate is the one we're going to pick. And that's going to be SO4 with a -2 charge. So we're going to write the symbol in charge for sulfate, SO4 -2. Now, you're going to flip-flop that, symbol in charge, crisscross reduce. So we're going to bring the 2 over here, and the 1 is going to go over here. So our formula is going to be H2SO4, sulfuric. Now, let's pick sulfurous, just to show you what the other one would look like. Sulfurous acid. Okay, I know it's an acid because it has the word acid, so I'm going to know it's going to start with hydrogen, so I'm going to put hydrogen with a +1 charge. Now, this is not an element because there's no hydro prefix, so this is a polyatomic ion. I just have to figure out which one. This ending right here is going to tell me which polyatomic ion to pick. So, because it ends in us, if the acid ends in OUS, I'm going to pick the ite version of that polyatomic ion. So it ends in us. That means I'm going to pick the polyatomic ion that ends in ite, and that is going to be SO3 with a -2 charge. So this is going to be SO3 -2. And then you're going to symbol in charge, crisscross reduce, and that's going to be H2SO3. And that's how you come up with the balanced compound for acids. Okay, so again, hydro, it's going to be paired with an element. No hydro, you're going to pair it with a polyatomic ion. And you're going to have to watch the ending of that acid to know which polyatomic ion you're going to choose to pair with it. Keep in mind, these are going to be treated like ionics, and that you're going to need to symbol in charge, crisscross reduce. I think that's going to be it. If y'all have any questions, let me know. I will post the practice questions along with keys to help you with working on some of this and getting a handle on coming up with formulas from names, because folks, again, you have got to know how to do this in order to be successful in everything from Unit 2 forward, okay? So again, as always, if you have any questions, just let me know.